Hello students, this is the second video of chapter 2 is matter around us pure. Here I am again to tell you more about is matter around us pure. So your first topic is concentration of a solution. A solution may have a small amount of solute dissolved in it, while another solution may have a large amount of solute dissolved in it. The solution having a small amount of solute is said to have low concentration. It is known as a dilute solution. The solution having a large amount of solute is said to be of high concentration. It is known as concentrated solution. See figure A and B. We can now define the concentration of a solution as follows. The concentration of a solution is the amount of solute present in a given quantity of the solution. The concentration of a solution can be expressed in a number of different ways. The most common way of expressing the concentration of a solution is the percentage method. The percentage method of expressing the concentration of a solution refers to the percentage of solute present in the solution. The percentage of solute can be by mass or by volume. This point will become more clear from the following discussion. If the solution is of a solid solute dissolved in a liquid, then we consider the mass percentage of solute in the calculating the concentration of solution. So, in the case of a solid solute dissolved in a liquid solvent, the concentration of a solution is defined as the mass of solute in grams present in 100 grams of the solution. For example, a 10% solution of common salt means that 10 grams of common salt are present in 100 grams of solution. Please note that the 100 grams of solution also include 10 grams of the common salt. This means that the 100 grams of common salt solution contain 100 minus 10 is equal to 90 grams of water in it. Thus, we can prepare a 10% solution of common salt by dissolving 10 grams of common salt in 90 grams of water. So, the total mass of the solution becomes 10 plus 90 is equal to 100 grams. Student, please note that the concentration of a solution refers to the mass of solute in 100 grams in the solution and not in 100 grams of the solvent. We can calculate the concentration of a solution in terms of mass percentage of solute by using the following formula. So, concentration of solution is equal to mass of solute upon mass of solution multiplied by 100. The mass of solution is equal to the mass of solute plus mass of solvent. So, we can obtain the mass of solution by adding the mass of solute and the mass of solvent. In the above given example, mass of solute, that is salt, is equal to 10 gram and mass of solvent, water, is equal to 90 gram. So, mass of solution is equal to mass of solute plus mass of solvent. So, mass of solute is 10 and mass of solvent is 90. 10 plus 90 is equal to 100 gram. Now, putting these values of mass of solute and mass of solution in the above formula, we get concentration of solution. Concentration of solution is mass of solute upon mass of solution multiplied by 100. So, 10 upon 100 multiplied by 100 is equal to 10% by mass. Thus, the concentration of this salt solution is 10% by mass. So, student, please note that if the concentration is in terms of mass, then the words by mass are usually not written with it. For example, in the above case, we just say that it is a 10% solution of common salt, since common salt is a solid. So, it is understood that the percentage is by mass. This is because we do not consider the volume of solids in making solutions. Clear? Suspensions. We have just studied that the substances which are soluble in water or any other liquid form solutions. Clear? But those substances which are insoluble in water form suspensions. So, what is suspension? In science, a suspension is a heterogeneous mixture in which the small particles of a solid are spread throughout a liquid without dissolving in it. Some common examples of suspensions are chalk water mixture, muddy water, milk of magnesia, sand particles suspended in water, and flour in water. Chalk water mixture is a suspension of fine chalk particles in water. Muddy water is also a suspension of soil particles in water, and milk of magnesia is a suspension of magnesium hydroxide in water. Please note that solid particles and water remain separate in a suspension. The particles do not dissolve in water. Clear? Now, we will study the properties of a suspension. Just see the picture. If we shake some chalk powder with water in a beaker, a milky suspension is formed. We can see the fine particles of chalk suspended throughout the water without dissolving in it. Clear? If this suspension of chalk and water is kept undisturbed for some time, the chalk particles settle down at the bottom of the beaker. What does it mean? It means that chalk and water suspension is unstable. If we filter the suspension of chalk and water, the chalk particles are left behind as a residue on the filter paper and clear water is obtained as a filtrate. This means that chalk and water suspension can be separated into chalk and water by filtration. And if a beam of light is passed through a chalk and water suspension, it scatters the beam of light and its path visible inside it. So, from this discussion, we get the following properties of a suspension. These are: number one, a suspension is a heterogeneous mixture. Number two, the particles of a suspension can be seen easily. Third, the suspension are unstable. Means the particles of a suspension settle down after some time. Clear? Fourth, a suspension scatters a beam of light passing through it. Why? Because its particles are quite large. That's why a suspension scatters a beam of light passing through it. Fourth, the particles of a suspension do not pass through a filter paper. So, a suspension can be separated by filtration. Clear? Let's move our next topic, that is colloids. A colloid is a kind of solution in which the size of solute particles is intermediate between those in true solutions and those in suspensions. The size of solute particles in a colloid is bigger than that of a true solution, but is smaller than those of a suspension. Though colloids appear to be homogeneous to us, but students, actually they are found to be heterogeneous when observed through a high power microscope. Clear? So, a colloid is not a true solution. Some of the examples of colloids, or we can say colloidal solutions, are soap solution, starch solution, milk, ink, blood, jelly, and solutions of synthetic detergents. Colloids are also known as colloidal solution. To study the properties of a colloid, if we shake some soap powder with water in a beaker, we get colloidal soap solution, which is not perfectly transparent. It is somewhat translucent. The soap particles cannot be seen by us. But if the soap solution is kept for some time, the soap particles do not settle down. If we filter the soap solution, the whole solution passes through the filter paper and no residue is left behind. So, all these observations indicate that soap and water mixture is a true solution. The scattering of light by a soap solution and the examination of soap solution under a high power microscope, however, show that soap solution is not a true solution. This point will become more clear from the following discussion. Listen, in a true solution, like sugar solution, the solute particles are so small that they cannot scatter light rays falling on them. For example, if a beam of light is put on a true solution, kept in a beaker in a dark room. The path of light beam is invisible inside the solution when seen from the side. The beam of light can become visible only when the solute particles are big enough to reflect light falling on them. Since the particles of a true solution do not scatter light, so we conclude that they must be very, very small. Clear? In a colloidal solution, the particles are big enough to scatter light. This can be shown as follows. If a beam of light is put on a colloidal solution, we can say soap solution, kept in a beaker in a dark room, the path of light beam is illuminated and becomes visible when seen from the side. The path of light beam becomes visible because the colloidal particles are big enough to scatter light falling on them in all the directions. This scattered light enters our eyes and we are able to see the path of light beam. Now, Tyndall effect. The scattering of light by colloidal particles is known as Tyndall effect. The scattering of light by colloidal solutions tells us that the colloidal particles are much bigger than the particles of a true solution, and hence colloidal solutions are not true solutions. So, a true solution can be distinguished from a colloidal solution by the fact that a true solution does not scatter a beam of light passing through it, but a colloidal solution scatters a beam of light passing through it and renders its path visible. In other words, a true solution does not show Tyndall effect, but a colloidal solution shows Tyndall effect. The particles of some of the colloidal solutions can be seen through a high-power microscope. For example, if a drop of milk is examined under microscope, we can see the small particles of fat floating in the liquid. This observation shows that colloids are heterogeneous in nature, though they appear to be homogeneous. You can see in picture A and B. Solution of copper sulfate does not show Tyndall effect. In picture B, mixture of water, milk shows Tyndall effect. Let us write down the properties of colloidal solutions. That is, number 1, a colloid or colloidal solutions appears to be homogeneous, but actually it is a heterogeneous. Second, the particles of most of the colloids or colloidal solutions cannot be seen even with a microscope. Third, the particles of a colloid can pass through a filter paper. So, a colloid cannot be separated by filtration. Fourth, the colloids are quite stable, means the particles of a colloid do not separate out on keeping. Fifth, a colloid scatters a beam of light passing through it because its particles are fairly large. Clear? Let's move our next topic, that is classifications of colloids. Colloids do not involve only solids and liquids. They may also involve gases. So, colloids are classified according to the physical state of dispersed phase. Dispersed phase, that is solute, and the dispersion medium, that is solvent. So, most of the colloids can be classified into the following 7 groups. That is, number 1, sol, number 2, solid sol, 3, aerosol, 4th, emulsion, 5th, foam, 6th, solid foam, and 7th, gel. All these are the technical names of the groups of colloids. We will now describe all these colloids in brief. Number 1, sol. Sol is a colloid in which tiny solid particles are dispersed in a liquid medium. The examples of sols are ink, soap solution, starch solution, and most paints. These are the sols. Second, solid sol. Solid sol is a colloid in which solid particles are dispersed in a solid medium. The example of a solid sol is colored gemstones like ruby. Third, aerosol. An aerosol is a colloid in which a solid or liquid is dispersed in a gas, including air. The examples of aerosols in which a solid is dispersed in a gas are smoke, which is soothed in air, and automobile exhaust. These examples of aerosols in which a liquid is dispersed in a gas are hairspray, fog, mist, and clouds. These are the examples of aerosol. Now, fourth, emulsion. An emulsion is a colloid in which minute droplets of one liquid are dispersed in another liquid, which is not miscible with it. For example, milk, butter, and face cream. Fifth, foam. The foam is a colloid in which a gas is dispersed in a liquid medium. The examples of foam are fire extinguisher foam, soap bubbles, shaving cream, and beer foam. Sixth, solid foam. The solid foam is a colloid in which a gas is dispersed in a solid medium. The examples of solid foam are insulating foam, foam rubber, sponge, and bread. Last, gel. The gel is a semi-solid colloid in which there is a continuous network of solid particles dispersed in a liquid. The examples of gel are jellies, gelatin, and hair gel. Clear? Student, this is your classwork of chapter 2, Is Matter Around Us Pure? Let's move question 1. Here one numerical is there. That is, a solution contains 40 gram of common salt in 320 gram of water. Calculate the concentration in terms of mass by mass percentage of the solution. So in this numerical, what is given here? Mass of solute means salt, is equal to 40 gram. And mass of solvent means water. So the mass of solvent is equal to 320 gram. Here we know mass of solution is equal to mass of solute plus mass of solvent. So 40 gram plus 320 gram is equal to 360 gram. 360 gram is the mass of solution. Clear? Now, putting the value of mass of solute and mass of solution in the above formula, we get concentration of solution or mass percentage of solution. The formula of mass percentage or concentration of solution is equal to mass of solute upon mass of solution multiplied by 100. So, mass of solute, that is 40 gram. Mass of solution, that is 360 gram. So, accordingly to the formula, 40 upon 360 multiplied by 100. The answer is 11.1%. Clear? Now, question 2. Which of the following will show Tyndall effect? Tyndall effect. As you know, the scattering of light by colloidal particles is known as Tyndall effect. The scattering of light by colloidal solutions tells us that the colloidal particles are much bigger than the particles of a true solution, and hence colloidal solutions are not true solutions. So, in the given examples, here milk and starch solution will show the Tyndall effect. Your homework assignment of chapter 2 is matter around a spew. Let's move to the questions. Question 1. Explain the following giving examples. Number 1, colloid, and second is suspension. Colloid. As you know, students, I have already explained you, a colloid is a heterogeneous mixture in which the size of the solute particles is so small that they cannot be seen individually with naked eyes and appears to be distributed uniformly throughout the mixture. The solute particles do not settle down when the mixture is left undisturbed. This means that colloids are quite stable. Colloids cannot be separated by the process of filtration, but they can be separated by centrifugation. It also shows the Tyndall effect. For example, milk, butter, foam, fog, smoke, etc. Now, suspension. Suspensions are heterogeneous mixtures in which the solute particles remain suspended throughout the medium. These particles can be seen with naked eyes. It shows the Tyndall effect. Suspension can be separated by the method of filtration. For example, mixtures of chalk powder and water, wheat flour and water, etc. Now, question second. How can we express the concentration of a solution? The answer is the amount of concentration of a solution can be written as by the two method or formula. Number one, mass by mass percentage of a solution is equal to mass of solute upon mass of solution multiplied by 100. Second, mass by volume percentage of a solution is equal to mass of solute upon volume of solution multiplied by 100. Clear? Now question 3. Write two examples of suspension. The answer is muddy water and chalk in water. Question 4. Write any three properties of colloidal solution. The answer is number 1, it is heterogeneous. Second, it shows Tyndall effect. Third, does not pass through the filter paper. Now, the last question. How are solution and suspension different from each other? The answer is sol is a colloid in which tiny solid particles are dispersed in a liquid medium. So, in this question, the term sol has been used to represent a colloid or colloidal solution. The main points of difference between solution, sols or colloids and suspension are given. That is, a solution. In solution, a solution is a homogeneous mixture. A sol appears to be homogeneous, but actually it is heterogeneous. Suspension. A suspension is a heterogeneous mixture. Second difference. The particles of a solution cannot be seen even with a microscope. In sol, the particles of most of the sols cannot be seen even with a microscope. The particles of some of the sols can, however, be seen through a high-power microscope. In suspension, the particles of a suspension can be seen easily. The third difference, a true solution does not scatter light. In sol, a sol scatters a beam of light passing through it. And in suspension, a suspension scatters a beam of light passing through it.